All right, this should be your video for Monday, March 8th. So last week after the test, we learned how to find the slope of a line that passes through 2 points. And we learned to find the equation of that line by going ahead and finding the y-intercept. So what we're doing today is really an extension of that. It might not look like it at first, but you just have to trust me that it is, okay? So instead of giving you 2 points and trying to determine whether what the slope is, I'm going to give you a table. Now a table will have several points. You guys made tables when we graphed a line by finding 5 points and then plotting those 5 points and making a line. Well, today you're going to be given a table and you're going to try to determine, does this table represent something that is a linear equation? And if it does, what is the equation of that line? So instead of just trying to find the slope using the y sub 2 minus y sub 1 over x sub 2 minus x sub 1 type thing, we're going to do a slightly different method, and then we'll find the y-intercept the exact same way. So what I'm going to do is look at my change in x. When I go from one point to another, so when I go from this first point to this second point, my change in x is plus 3. When I go from the second to third point, negative 3 to 0 is plus 3. 0 to 3 is plus 3. 3 to 6 is plus 3. So I have a change in x of 3 every time. Now I'm going to do the same thing for change in y. So negative 2 to 0, kind of looks like a smiley face. Negative 2 to 0 is plus 2. 0 to 2 is plus 2. 2 to 4 is plus 2. And 4 to 6 is plus 2. So I'm going to look at change in y over change in x and see if there's a constant rate of change, aka slope. Does the change going from these points represent something that is constant? That constant rate of change is what we call slope. So when I went from this point to this point, change in y was 2, change in x was 3. So that would be 2/3. Here to here, I'm looking at this row, is 2/3, 2/3, and 2/3. So when I go from the first point to the second point, the rate of change was 2/3. When I go from the second to third, it's 2/3. The third to fourth is 2/3. The fourth to fifth is 2/3. So yes, this is linear because there is a constant rate of change. And now we're going to find the equation of that line. Well, this is my slope. So I have that part done. So now I just need to take what we did last week, not yesterday, last week, and find the y-intercept, and that way I'll have the equation. You can pick any of these 5 points, and you'll get the same answer. So we'll start with y equals mx plus b. I'm going to pick this point 3, 4. So that means y will be 4. M is 2/3. X is 3 plus b. So 3 divided by 3 is 1. 1 times 2 is 2. Subtract 2, and I get b is 2. If m is 2/3 and b is 2, the equation of this line is y equals 2/3 x plus 2. Now, where people mess up There are several ways where people mess up. The first way is that they realize there's a 3 up here and a 2 down here, so instead of putting change in y over change in x, they put 3 over 2, 3 over 2, 3 over 2, 3 over 2. Do not do that. It's change in y over change in x. Tables are always listed x, y, but our rate of change is change in y over change in x. So it'll have to end up flipping over, okay? The other way people make a mistake is that instead of looking at the rate of change and looking at it closely, they look up here for a pattern and they look down here for a pattern. Do not look for a pattern. Okay? I will go ahead and confess right now, if there is a recognizable pattern, it is linear. So you might be asking, well, why don't you want me to look for a pattern? Because if there is not a recognizable pattern, sometimes it is linear, sometimes it is not linear. So never look for it because it can trick you into thinking it's nonlinear when it is. Instead, take the time to write these rates of change and analyze it that way. Trust me, you'll have an example coming up that'll probably trick some of you. Okay, so do not look for a pattern, look for a constant rate of change. And make sure you put change in y over change in x instead of the other way around. I will say on this one, there is a shortcut. If you remember that the y-intercept is where the line crosses the y-axis, and we said, well, that x value is always 0, and we don't know the y can be something different every time. Sorry, it's about 10:30 at night on Wednesday, so I'm starting to stutter my words here. I'm getting a little tired. If x is 0, we know we're on the y-axis. Well, look right here. X is 0, and look what y is. It's 2. Well, look what our y-intercept was. It's 2. In other words, if I give you an x value of 0, you don't have to do all this work. You can just say 2 is my y-intercept. You can skip a whole lot of work. It's not a bad shortcut. It'll save you a lot of time. All right, let's look at another example. We got -7, 16, -6, 13, -5, 9, -4, 6, and 3, 3. -3, I should say. So let's find our change in x between each point. -7 to -6 is +1. -6 to -5 is +1. -5 to -4 is +1. -4 to -3 is +1. Don't look for a pattern. Don't do it, don't do it, don't do it. Change in y. 16 to 13 is -3. 13 to 9 is -4. 9 to 6 is -3, and 6 to 3 is -3. So we're going to look at our rate of change, which is change in y over change in x. We're going to look and see, does this thing have a constant rate of change? Constant meaning it never varies. Change in y over change in x is -3 over 1. Change in y over change in x is -4 over 1. -3 over 1, -3 over 1. Right here, it's different than all the other ones, which means it is not constant. We could do this 1,000,000 times. And 999,999 times, we could have -3 over 1, and 1 out of 1,000,000, we could have -4 over 1, and it is non-linear. Okay, math is very literal. When it says constant, it means do not change one time. So we changed one time, so this is nonlinear because there is not a constant rate of change. And since this is nonlinear, we don't have to find the equation. We know how to find the equation of linear equations. This one's nonlinear. We don't know how to find the equation of this. So we're not going to worry about it. Move on to the next one, okay? You'll have 5 of these for homework. You'll have 5 of them Monday night, Tuesday night, and Wednesday night. We're going to kind of stick with this and get good at it. All right, let's do another example here. We have 2, -7, 4, -8, 6, -9, 8, -10, and 10, -11. So let's first find our change in x. That's +2, that's +2, that's +2, that's +2. Let's find our change in y. -7 to -8 is one smaller. So all these end up being -1. I know there's a pattern there. I know that means it's linear, but don't look for a pattern. Don't do it, don't do it, don't do it. So change in y over change in x, -1/2. -1/2, -1/2, -1/2. So yes, there is a constant rate of change, so this one is linear. So now we're going to find the equation. This right here tells me that m is -1/2. I did not give you an x value of 0, so you can't use that shortcut I just told you about. So we have to pick a point. I'll pick this one. I'll pick 4, -8. You can pick any of those points, and as long as you know how to add, subtract, multiply, and divide, you'll get the same answer that I did. So y equals mx plus b. Y is -8. M is -1/2. Oh, my nose itches. X is 4, and B is what we're looking for. Negative and a positive make a negative. 1/2 of 4 is 2. Add 2 to both sides, and I get B is -6. There's M, there's B. So my equation is y equals -1/2 x minus 6. Right. So it's linear because there's a constant rate of change. That constant rate of change is -1/2, not 2/-1. Don't forget to put change in y over change in x. All right. We're going to do 3 more. So we're halfway there before you get a chance to start working on your own homework. All right, -18 and -23, -15 and -19, -12 and -14, -9, -9, -6, -4. So let's look at change in x, +3. +3, +3, +3. Let's look at change in y. +4, +5, +5, +5. let's look and see if it has a constant rate of change or not. The first point is, first to the second point is 4 over 3, then 5 over 3, then 5 over 3, then 5 over 3. So we got this odd duck here, nonlinear, because there is not a constant rate of change. Again, we're not going to find the equation. You can't find the linear equation to a nonlinear example. All right, 2 more. All right, we have negative 10, negative 11, negative 8, negative 8, negative 2, 1, positive 2, 7, and 10, 19. So let's look at change in x. That's plus 2. This is plus 6. A lot of people mess this up because it's going from a negative to a positive. 0's in between, so you can kind of ask yourself, how far is negative 2 from 0? It's 2 away. How far is 2 away from 0? It's 2 away. 2 and 2 make 4. So this is 4 bigger, and this is 8 bigger. Change in y, we have plus 3, 8 away, 1 away, so that's 9 away, 9 apart, 6 apart, and 12 bigger. So if we look at change in y over change in x, this is 3 over 2, this is 9 over 6, this is 6 over 4, and this is 12 over 8. Do not look for a pattern at all. Don't do it. Don't look for a pattern. Because if you look for a pattern, there's not a pattern here. But if you look for a constant rate of change and reduce your fractions, it's there. 3 goes into this 3 times, it goes into 6 2 times. 2 goes into 6 3 times, it goes into 4 2 times. 4 goes into 12 3 times, it goes into 8 2 times. The rate of change is 3 halves, 3 halves, 3 halves, 3 halves. There is a constant rate of change. This one is linear. Because there is a constant rate of change. So since we found that constant rate of change, we now have to find the equation of this line. So I did not give you an x value of 0, so we cannot use that shortcut. I'm going to use this point right here. It's nice small numbers. Negative 2, 1. So let's start with y equals mx plus b. Y is 1, m is 3 halves, x is negative 2, and b is what we're looking for. So you get 1 equals a positive times a negative is a negative. 2 divided by 2 is 1. 1 times 3 is 3. Get rid of that negative 3 by adding 3. And I get 4 equals b. So there's b. M we already said was 3 halves because of this. So we know m. So our equation is y equals 3 halves x plus 4. let's do one more of those. And then we'll call it a wrap for the video. All right. We have -3, -3, 0, -6, 1, -7, 5, -11, and 7, -13. Let's find the change in x. So -3 to 0 is +3, 0 to 1 is +1, 1 to 5 is +4, and 5 to 7 is +2. Let's find the change in y. -3 to -6 is 3 smaller, so that's -3. -6 to -7 is -1. -7 to -11 is -4. And -11 to -13 is -2. So let's look for our rate of change. Change in y over change in x. That's -3 over 3, -1 over 1, -4 over 4, and -2 over 2. All of these simplify to -1. -1, -1, -1, -1. That means our slope is -1. Maybe you saw it, maybe you didn't, but I gave you an x value of 0 right here, which means this is our y-intercept. That saves so much time if you recognize that. If you don't believe me, go ahead and plug some numbers in. You're going to get the -6, but if you want to waste your time, go ahead. That means our equation is y equals -1x minus 6. You'll never, ever, 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 ever see it written that way on a multiple choice. Technically, you should simplify it, so let's do that. -1 times x is -x minus 6. I'm not going to be super picky and mark that wrong, but you'll make me smile if you do this instead. And we all know that you live to make me smile. So, all right. You have a homework worksheet that's called XY Table 1. Or actually, it's just called XY Table Worksheet. Tomorrow's going to be called XY Table Worksheet 2. Then Wednesday's going to be XY Table Worksheet 3. Thursday, you'll have a review over what we did last week in this table stuff. Friday, you'll have a quiz over both. That's your week. See ya.